Right, and welcome to the 2025 question B2. This is an intersecting planes question. The image on the right shows an indoor adventure centre in Abu Dhabi. The building includes a series of intersecting planar triangular surfaces, as we can see here on the right. Figure B1 or B2 shows the plan and elevation of three intersecting planes, so our plan and elevation. The horizontal and vertical coordinates for points A, B, C, D, and E are given. Okay, so we've got our A, B, C, D, E. All right, we're going to measure out, up, and down. All right. Part A, they want us to draw the given elevation and plan of the intersecting planes A, B, C, A, B, D, and C, D, E. So we just want to draw the plan and elevation. So we're using our coordinates for that. All right. So my XY line . All right, and we'll measure from the side of the page. We're going 130. Yeah, so we're going 160. That's my A. 130. It's going to be B. 200. We C. 110. For D, and point E is 190. So that's E. All right. So let's draw our lines up and down. Okay. So we'll go to A. So A, we're going up 0, so that's going to be a point there, A. We're going down 95, so down 95, A. Point B, over here to B. We're going up 20, down 30, so up 20, down 30. That's going to give me B. And B. Then we're going to C, 40, 50. So C was over here. I'm going up 40 and down 50. C. And then D is 70, 75. So D is 70 and 75. D. D. And finally E is 100. 105 and 10. So there's my E. E. Okay, I want to draw those planes as they're presented. So we've got A, B, C. B, C, D. I've actually got C, D, E there also. So those are three planes in elevation. Now we need to draw them in the plan. So I've got, nice, they've got hidden detail given to us. So I'll draw the heavy lines first. I know where hidden detail needs to go. And then I can join these up. So C to B. And then CA. Okay, so draw a given elevation and plan, done. Determine the dihedral angle between the planes ABC and BCD. So BC, BC, that's my line of intersection. Okay, so I don't need to find a line of intersection, it's been given to us. All right, so we've got BC, actually let me just get a pen and I'll highlight that. So BC and BC. Okay, so that's my line of intersection, the LOI. LOI. Okay, so the steps we've learned for finding a dihedral angle is line of intersection, which we've got. We need to find a point view of the line of intersection, and then, a true length of the line of intersection, and then a point view of the line of intersection. Okay, so let's see. I'm going to project out from my plan view to find a true length. So here's my second set square. There we go. Okay. So out here, my x1, y1. Okay, x1, y1. And we will project all of these out, all these points for just these two planes out at 90 degrees to that. Okay, so just set this up. So we want C, A, we need B, and D. Okay. Now let me just move the camera there a bit. All right, so we're projecting from the plan, which means we're creating an auxiliary elevation. So heights are taken from the elevation. All right, let's start with A. A has 0 height, so there's A. Okay, B, that's my height for B. And if you wanted, you could just be taking the heights from the question. All right, but it's good practice just to follow the steps that we know. So there's B, C, C down, and D. There's my D. Okay, so let's draw our planes. Sorry, that's C, that's B, and that's D. Okay, so we'll draw planes A, B, C. And C, B, D. Okay, and I'll highlight my line there again. So that's the true length of the LOI, the line of intersection. So that's the true length of it. All right, so now we want to find the point view of that. All right, so we're going to look out along that point, or that line. All right, so slide set squares again. I'll set up my line there like so, slide back. Here's my x1 or x2, y2. x2, y2. I'm going to project out all these points through there. BC and D. Okay. So when I was getting the heights for down here, I went back 1, 2 views. Okay. I'm getting them from here. I go 1, 2 views. So from my X1, Y1 back to plan. So let's go for A. That's my distance for A. Follow A out, and that will be my new A. For C and for B, just to show you, we should be finding a point view of that point or that line. So it'll be the same distance for B and C. So BC, we have it there, and then D, step off for D. So I've got A, BC, and D. So I got an edge view of BC and an edge view there because this is a point view. Okay, so that's the point view of the LOI, which is BC. Okay, so all I have to do now is measure that angle. Okay, so set my set square there. I'm getting that at about 76 degrees. Okay, should highlight that. 76 degrees. That's my dihedral angle. All right. So that's dihedral angle complete. Okay, let me just tidy up my workspace a bit. So now they want us to determine the true shape of surface CDE. So CDE is this surface here, and we haven't done anything with CDE as of yet. So if I want to find the true shape of a surface, I must first find an edge view of it, okay? And if I look around here, CDE, CDE, okay, it doesn't exist, okay? So I need to find an edge view of a surface, okay? So what that means is I need to, if I want the edge view of a surface, I need a line on that surface seen as a point view. So I need a true length line on that surface. As it stands, none of these lines are true lengths. So I need to draw a horizontal line on that surface. Okay, so let's go with my green here. That's going to give me a level line or a horizontal line, okay, from D. I could have done it from anywhere, but from D because we already have a reference there for D. So on that edge then, CE, let's find that same point, CE, down here. And now I have a horizontal line in plan. Okay, so horizontal lines in plan are true length lines. Okay, same way as if I put my pen there on the desk, which is a horizontal plane, it's on a horizontal line, I measure it. So that is a true length line. So what I'll call this is a level line LL, and this is the true length of LL, level line. So we're going to look out along that, and that will give us an edge view of that plane. So sliding set squares again. Lining that up, we're just dealing with the plane CDE. So project out, project out, project out. Let's find my X1, Y1. x1, y1. Okay, I'm projecting from plan, so I'm creating an auxiliary elevation, which means height's taken from the elevation. So my compass. Let's get my distance here for C. Follow C down, step it off. So there's C, E. Here's my point E, and then D. There's D. All right, as you can see, we're getting a straight line. Okay, so that's, sorry, I'll label them up again. E, D, and C. Okay, and right there, because we're looking out along it, we're getting a point view of that true length line. Okay, so edge view. Now we want to find the true shape, so we're going to look perpendicular to it. Okay, so it's like we've found an edge view of our plane here, and now we want to come out, look around, so we see the actual shape of it like that. So sliding steps first again, x2, y2, set it up parallel to my plane. Let's go there. I'll project out through it then. Okay, so that's my, sorry, x2, 2. Okay, so we're going 2 views back, so take my distance from my x1, y1 back to plan. So here's the distance for C, and follow C out. My distance for E, and there's E. And then D, there's a nice long distance. Follow D out. So I'll extend this line out to find my D. So D, C, and E. Okay, if you need to use a datum, if it's going off too far off the page, okay, you can always draw a line back here parallel to my x1, y1. Okay, but there I have my true shape of CDE. Okay, all right. So that is the true shape found. Okay. Lastly then, determine the horizontal and vertical traces for the plane ABC. So ABC, right? They're asking us if we were to extend on this plane, where is going to hit the horizontal plane and the vertical plane. All right. So for that, we're going to have to extend the plane. So we're going to AC, C is already touching the ground, okay? Or sorry, A is already touching the horizontal plane. Okay, so that's going to be a point on my HT. So we're going to extend BC now as well. Okay, so BC, let's use a color here. I'll get my orange. So it's a line extension. So BC, let's extend it down until it hits the horizontal plane there. All right, so that's where it hits the horizontal plane. So I'm going to show that. It's somewhere down along here then. Okay, on the horizontal plane. Right, so if I extend BC again, I'll find that exact point. So BC, extended. Okay, so that will be a point on my HT. And like I said, we already have AC, or point A is on the horizontal plane. So that is my HT line. Okay, so HT. Okay, and just show that that was extended down and that was extended down. All right. Now I want to find a point on my VT. Okay, I could do line extensions again, so I could extend C out until it hits the vertical plane, or what I like to do is a horizontal section. Okay, so let's go parallel to HT. So this is similar to what came up in question A3 on this here. So we'll go parallel to it. Okay, so that's going to result with it as a horizontal line. Okay, because it's a horizontal line HT. So this is also parallel to it, so it's a horizontal line. So from B there, it's a horizontal line. Here's where it hits the vertical plane. So I'll bring that up to see exactly where it hits the vertical plane. And now I have my VT, vertical trace. VT. Okay, so that is part 3 completed. My vertical trace and horizontal trace. Okay, so that was a nice question there on that year, a nice intersecting planes question. Pretty standard one asking, set up your question, dihedral angle, horizontal and vertical trace, and a true shape. It's pretty standard kind of a question, a nice one covering all bases. Nothing tricky there.